All right, and we're back in the same topology, right? Why try to reinvent the wheel? We have our little topology right here. All right, so we're going to do RIPng. All right, the rules of RIP remain the same; they don't change. It's still based on hop count, same hop count limitation. Obviously, in IPv6, there is no broadcast. Everything is multicast, but like revision 2, it's still used at 224.0.9 to send its updates out. Here we'll be using, instead of 224, it'll use a FF02 colon colon 9 to send its information. So it just converted 224.0.0.9 into an IPv6 address. All right, but the rules still remain the same. The configuration, though, however, there is no more network statements. There is no auto summary, which is pretty cool because now they've implemented a process ID number, or if you want to call it that, for RIP. So it has an actual RIP routing process. So I'm going to show you two ways. We'll do it one way on this router, and then we'll do it another way on this router. All right. So the cool thing is that we don't have to worry about the network. Because now we actually do it on the interfaces. All right. So let's start with router one. You'll see what I'm talking about. So here we're going to enable RIP globally, right? Like we kind of used to doing, right? So we're going to go IPv6. Everything starts with IPv6. Router RIP 1. This is where this process number comes in. You hit enter. Now you can see here they got all these choices. You can change administrative. You can exit. You can say no to take the command out, or you can redistribute into other routing protocols. We're not going to do any of that, all right? Because CCNA, that's a question I get asked a lot. Hey, Lazo, we're going to do any redistribution? If I show a lab on redistribution, it's very rare because I want to keep the class focused on just what you need for the CCNA. Trust me, once you get to the next levels, you get a lot more redistributions. So you'll see a lot of it. Don't even worry about it. So you can see that's basically it. That's all you do there. Now we need to put that RIP routing process that we enabled, we need to put it into the interfaces that we want to participate in this process. So no network statements. So I'm going to go into interface G0/0. Okay. I'm going to say IPv6 router. Router RIP. Oh, I'm sorry. Not router RIP. IPv6 RIP 1 enable. Okay. Hello. That's it. How simple is that? Okay. G01. Not that anybody's going to be configuring RIP, right? But I mean, poor RIP gets a bad rap. Okay. And then we enable it in that interface. So if you don't want RIP enabled on an interface, then don't put it, and it won't be enabled. It won't participate. Control Z, WR. Now, of course, for all of you taking the test, exit, exit, copy run start. All right. So if you look at the start, you can see IPv6 router RIP1 is enabled globally, and we have it here on each interface. All right. That actually has an IP address on there because these are the interfaces that are participating. All right, let's go to the other side. Do the same thing. But this time, instead of doing it globally, I'm just going to go straight into the interface. All right, so we're going to do it two different ways and see what happens. Int G0/1, enter, IPv6 RIP 1 enable, and then G00 IPv6 RIP 1 enable. I mean, seriously, can't get no faster than that. But this is what I wanted you to look at. It's pretty interesting. Show start. At least I found it like, oh, cool. It doesn't work that way with EIGRP. It does, but you got to do certain things in EIGRP in order to make it work. Look, it enabled it. I just went into the interface and enabled the interfaces, and it actually went ahead and created it globally as well. That is cool. All right, so it's becoming easier, really, to deal with IPv6. Obviously, as the enterprise gets bigger, it's going to get a lot more complex. There's little gotchas here and there with the routing protocols and depending on the topology, if you're going to cross an MPLS or a DMVPN or what have you. So there's different things, scenarios that you can create that say, hey, oh my God, this is, but again, CCNA certification, ladies and gentlemen. Focus on the exam. All right, once you get your CCNA, then you can, okay, whatever, and keep on going. All right, let's take a look at the routing table now. Show IPv6 route. And now you can see that we are receiving a RIP update from the 2000 network, which says it's 2 hops away. All right, so you see the administrative distance of RIP doesn't change, and the actual, the hop count, all that still there, still there. All right, so let's see if we can go ahead and ping across. Let's go to PC2, and I'm going to paste, most definitely. All right, let's ping the PC. Let's go straight for the PC. All right, this is the server, 1000:1, and I can ping. All right, let's go for the PC, and I can ping. So you see, it's not that difficult. Okay, when you're first starting out, it looks kind of weird. All right, because the only thing that's weird is this. Like, oh my God, look at all these numbers. But you can see that the focus. And if you guys, get my book, the all you need to know about IPs, that's on Amazon, that I wrote on IPv4 and IPv6, it's just all we basically just deal with is this portion of the address, which is the network prefix. The interface ID, which is this side, which is also another 64 bits. I mean, you can actually put 1, 2, 3, 4. You can put whatever you want, really. All right, as long as you don't break the rules of, no 2 double colons. Obviously, don't go above F. Okay, things of that nature. Okay, leading zeros you can take out because you see, really, this means that it's all zeros and 1. Right. So in each section, right, let's say for this right here, the first 3 sections on this side, which is the interface ID, will all be zeros, and then you have a 1. So instead of putting all zeros, you can get rid of the leading zeros. But again, you know that from the CCNA course. So you can see RIP is not that bad. Same administrative distance. So that means for the next lecture that we're going to do EIGRP, we really can do it on the same lab, right? And EIGRP is just going to take over. All right. So with that said, I hope you got this. I will see you in the next lecture.